So in 5.6, we are looking at law of cosines. We are going to be working with two situations here, side angle side and side side side, and how we use that law of cosines to solve the type of triangle. We also will look at a couple of different area formulas, not requiring that we know a base and an altitude. And then tomorrow we will look at applying that law of cosines. So the law of cosines states that if we are looking for a side, we would need to know its corresponding angle. And the formula says a squared plus b squared, a squared equals b squared plus c squared minus 2bc cosine a. And the other two are just the same pattern. Okay? Just remember that this letter and this letter have to match. Okay? All right, first example. We are given a triangle. We are told side A is 11, side B is 5, and the angle in between them is 20 degrees. Okay, so we have a side angle side situation. We are only given one angle, that angle C, which means the very first thing we're going to have to figure out is side C. Okay? We can't find anything else until we know that missing side. All right, so we're looking at the bottom version here. C squared equals A squared plus B squared minus 2AB times the cosine of angle C. Okay, plugging our numbers in. A is 11, so we have 11 squared. B is 5, so 5 squared minus 2 times 11 times 5 times the cosine of 20 degrees. How do we find C if we've calculated C squared? Take the square root. So what you're going to do is you're going to put in your calculator the square root of all of this. You should be able to enter it all as one step on your calculator. Again, make sure your calculator is set in degree mode. There's some on my desk. What are we getting? 6.529. Okay. All right, so we found the missing side, and now we're going to work to figure out the missing angles. Okay? As soon as we know two angles, we can find the third one easily just by subtracting from 180. But we are going to use law of cosines here to find the other angles, or the second angle. All right, so I'm going to find angle A, which is my biggest one. Okay, opposite the biggest side. All right, now how am I going to do that? Well, I have to look at my formula. Let's go back to our formula sheet up here. I want you to actually write a conversion. How would we use this to find the angle if we know all the sides? Okay, so looking at this first one here, we have A squared equals B squared plus C squared minus 2BC times the cosine of A. If we wanted to get cosine of A by itself, what would we need to do? Okay, so we need to subtract that B squared and C squared piece. Okay, so let's do that first. We're going to have A squared minus B squared minus C squared. That would then equal negative 2BC cosine A if we got rid of the B squared, C squared. How are we going to move the negative 2BC away from the cosine of A? We're going to divide it out, because right now it's being multiplied to cosine A. We're going to need to divide it out. So if we divide this whole thing by negative 2BC, that would be equal to the cosine of A. And you can do that same thing for angle B, angle C, right? Follows the same pattern. Yes?
Since you know all the sides, could you also use like the inverse trig options?
If it's a right triangle, you can use SOHCAHTOA. but we don't have a right triangle. We don't know that we do. Okay, so we're going to find angle A using this option. Okay. What do we do to undo cosine? Okay, so angle A is going to be the inverse cosine of that whole mess that we just wrote down. A squared minus B squared minus C squared divided by negative 2BC. Questions on how I got that formula? Okay, so let's plug in what we know. A was 11, so we have 11 squared minus 5 squared minus what we just found for C, which was 6.529 squared, all divided by negative 2 times 5 times 6.529. Okay, now, how are we going to type that in our calculator? Most students make mistakes because they type in 11 squared minus 5 squared minus 6.529 squared divided by negative 2 times 5 times 6.529. You have to divide by this whole thing on the bottom. Okay, so you're going to need an extra set of parentheses there unless you do that multiplication first and know what the number is. Okay, so use your calculators, go ahead and try it. What are we getting? 144.832? Yes? Okay. And now we actually know two angles, right? We were given the 20-degree one. We now found the 144-degree one. So we can just subtract them from 180 to get our third angle, which would be, in this case, angle B. All right. What do we end up with? 15. Okay. So have we solved the triangle? We found the one missing side and we found the two missing angles? Yes? Okay. There's a little note at the bottom here that said, once we found that side C, we had angle C being 20 degrees and we had side C being 6.529. So we knew a ratio of an angle to a side like we used in law of sines. So if we had a known angle ratio, angle side ratio, we could have shifted to law of sines instead of using law of cosines to find that angle. The problem comes in with knowing, are we looking for an acute angle or an obtuse angle? Because if you use law of sines and you're looking for, say, you end up with the sine of your angle being 0.7, something like that, okay? And you go to do inverse sine to figure out the angle. It's going to give you this reference angle, but there's another angle that has that same sine value of 0.7 in quadrant 2, right? So you aren't going to know if they want this little angle or they want the big angle. If you stick with law of cosines, it's automatic. The angle you get out is automatically your answer, because within 0 to 180, right, which would be the degrees you're allowed for a triangle, okay, we get two different cosine values. On here, cosine is positive. In this quadrant, cosine is negative. Okay, so if you get an angle as, say, cosine of A is negative 0.7, then you know you're looking for the obtuse one in quadrant 2. Okay, so if it's a situation where we use law of cosines to find missing sides, right? Side angle side, 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 I would stick with using law of cosines. Even though it's a little harder, it's a more complicated formula than law of sines, it's going to make it very clear which answer you're looking for. Okay? All right, let's look at one where we're given the three sides and none of the angles. So I want you to put a little note at the top here. Find largest angle first. Find the largest angle first. Well, which of my three angles would be the biggest in this one? How do I know it's angle A? Right, the side opposite's the biggest side? Okay, so we're going to start out finding angle A. And it is the inverse cosine of what? Let's think about that formula we wrote down. If we're finding angle A, we start with side A. Okay? And it's the only place you're going to use A. So we have A squared, then what? Minus B squared and C squared over. Okay, so again, if we are finding angle A, we start with side A, and it's the only place that you're going to use A. Everything else would be B's and C's. Okay? Let's start looking at the patterns involved here. All right, so angle A will be the inverse cosine of 9 squared minus 7 squared minus 5 squared divided by negative 2 times 7 times 5. So what is the bottom number going to be in the denominator there? Negative 70. So if you want to just type it in divided by negative 70, you can do that as well. All right, what do we get? I'm getting 95 something. 95.739. Yes? Okay. At this point, because we started and found the biggest angle, if I know that angle A is 96 degrees, what do I have left for angles B and C? About 84, right? And if I have to split that between two angles, we know that both of those are going to be acute, right? So there isn't that question of, is it looking for the quadrant 1 angle? Is it looking for a quadrant 2 angle? So because we found the largest one first, we could shift to law of sines here. Okay, I'm giving you that option. However, I'm going to show it using law of cosines just so you get one more chance to practice that formula. Okay, but you could move to law of sines if you find the biggest angle using law of cosines. Okay, all right, so if we are going to find, say, angle B next, thinking about that same pattern we had for finding angle A, we would have cosine inverse of what? It's going to start with a B squared, right? Because we're finding angle B. So we'd have B squared minus the other 2. And we're going to divide by negative 2 times the other 2. Right? Start to learn those patterns. Okay, let's plug our numbers in. B was 7, so 7 squared minus 9 squared minus 5 squared divided by negative 2 times 9 times 5. And if you had typed that whole calculation in as one step for finding angle A, you could recall it and just tweak a couple of the numbers. Okay, it'll save you some time. right, what are we getting for angle B? Thank you. And then how would we find angle C? Yeah, that's the easy one, right? Once you know two angles. 180 minus 95.739 minus 50.704. So what do we get for angle C? 33.557. All right. Questions on using law of cosines? Anybody? It's definitely a more complicated formula than law of sines. Okay, but again, there's patterns to it. If you start to figure out the patterns, it's going to be more manageable. Okay, the last two examples we're going to look at deal with finding area of triangles. It says the same parts that determine a triangle also determine its area. If the parts happen to be two sides and an included angle, we get a simple area formula in terms of those three parts that does not require us to find the altitude. Okay? Now, once again, we are giving you three versions of this. You are going to just be using one of them. Okay? So the formula says the area of a triangle is 1/2 the two given sides times the sine of the angle in between those two sides. Okay? So if you are given side, angle, side, right? So we know this, and we know an angle. My area would be 1/2 x times y times the sine of theta. Okay? So very useful if you're given a side angle side situation. Easy calculation. For our example, it says we want to find the area of a regular octagon, which is an 8-sided figure. 8 sides are all equal. The angles are all equal. Inscribed inside a circle that has a radius of 9 inches. So what has been drawn for you is one little section in that octagon. How many of those little triangular sections would we have? We'd have 8, yes? Going from the center out to each of the points. Okay, so just picture we have 8 of these little triangles going around. So if we know the area of one of the triangles, we can just multiply by 8 to get the full area. Okay? So looking at the original one that we were given, we are told the radius of the circle is 9. So the two sides would both be 9 inches. All right. How are we going to find the angle in between them? How many degrees in a full circle? 360. So we could take 360 and divide it by 8. Okay. So theta would be 360 divided by how many chunks you're dividing it into, which in this case we have 8 of those pieces. So each of those little angles would be 45 degrees. Okay. So now we want to find the area of that triangle. It's 1/2 the product of the two sides and the sine of the angle in between them. So our two sides are both 9s, and our angle is 45 degrees. Now we're actually going to do this without a calculator for the first part here, because we want an exact answer, because we don't want to round too early. That changes our final answer if we round early. Okay, so we have 1/2, 9 times 9 is 81. What's the sine of 45? Yep. So if we multiply this out, we get 81 root 2 all over 4. Okay, that's the area of one of those little triangular sections. So now to find the area of the whole octagon, we just need 8 of those. Bless you. So 8 times 81 root 2 divided by 4. What can we do with the 8 and the 4? It just reduces to 2. So 2 times 81 would be 162 root 2. Now that would be the exact answer. And because everything was measured in inches, our area would be inches squared. if you were going to do some kind of calculation or just needed a rounded estimated answer, we could get a decimal approximation for that. What is 162 root 2 approximately? 229? 103? Okay. Questions about that formula? All right. We have one more area formula, and this one is used when we have all three sides given. All right. But it's not necessarily a nice right triangle where we would have a base and a height. Okay. It's called Heron's formula. It says let A, B, and C be the sides of a triangle, and let S denote the semi-perimeter. Semi meaning half. So we want half the perimeter. Okay. So S is going to be the sum of all three sides divided by 2. Okay. So let's try that on this example 4. What is my semi-perimeter? I need 13 plus 15 plus 18, all divided by 2. What do we get? Okay, so my semi-perimeter is 23. And then what we do with that to find the area is this piece. It says take the square root of that semi-perimeter times the difference between that answer and each of my three sides. So S times S minus A times S minus B times S minus C. So my area here is going to be 23 times 23 minus 13 times 23 minus 15 times 23 minus 18. Well, what's 23 minus 13? So we have 23 times 10, 23 minus 15 is 8, 23 minus 18 is 5. Well, what do we end up with? If you give me an exact answer, it's the square root of, what's the big number? 9,200. Okay, which is approximately 95.917. They did not tell us the side lengths, what unit they were measured in. This would be square units, whatever that unit happens to be. Questions on Heron's formula? Okay. So you are doing day 1 today.